Okay, so these problems are going to seem even more than they did before, like what you did kind of in geometry class, or when you did proofs. So when we've been simplifying identities, and now we are going to begin what's referred to as verifying identities. And they look a little bit different because you're going to see an equal sign in the problem. So we've got to kind of talk about that. So what we are doing when we verify an identity is we are truly just proving or showing that both sides of the equation are equal or are the same, okay? The process that we're going to use, if you notice it says, for all values of the variable, in other words, any number that you can think of, any degree measure that you can think of for x or theta or whatever, that you plug in there, it would be true for any of those values. That's what makes it an identity, right? But if you notice it says, this is done by transforming the expression on one side, and that's really important, one side of the identity into the expression on the other side through a sequence of intermediate expressions that are each equivalent to the first. So we're going to use the same process that we've been doing. We are going to continue to simplify like we've been doing, using our identities to rewrite and use a little bit of algebra and mathematical thinking, all of those types of things. We have some tips to go over, but more importantly, notice what I've highlighted down there. You are not solving equations. So the tendency is to see, especially like if you look at this first example where you see this tangent of x minus 1, the tendency is to think, oh, I could add 1 to both sides. That might help things. We are not solving equations. In fact, when we are verifying these identities, we want to work with just one side. And my suggestion is that you actually kind of draw a line down the middle where you see the equal sign to help remember you're strictly going to work on one side or the other. So what we're going to look for is the more complicated side. So let's look at the tips, and that is actually the first tip there, is it says work with the more complicated side, right? And then when terms are squared, think Pythagorean identities. More than likely we're going to be dealing with the Pythagorean identities. If we're given parentheses, if we're given something that could be distributed, we're going to want to distribute. That's what number 3 is basically talking about. We may have to factor, and we're going to practice factoring day 2. If we're adding fractions or subtracting fractions, remember we need a common denominator. So we're going to do what number 6 says, and that is multiply by a value of 1. In other words, we've got to multiply to get our common denominator. If you guys don't do anything else, you should definitely at least change everything in terms of sines and cosines. So I'm going to give you a little bit of a, bear with me, you'll understand what I'm getting at here in a second, right? So some new piece of technology comes out, and what do you guys do? Don't say go buy it. That's what somebody in first period said. Yes, obviously you go buy it, but then what? Do you read the directions? No. What do you guys do? Turn it on and start pushing buttons and playing with it and figuring out how it works, right? Okay. People in my generation, your parents, me, we are afraid we're going to break this technology. So we hold it in our hands and we act as if we are going to break this, and we don't try anything. We don't figure out how to use the new technology because we're scared we're going to break it. And so we hand it to you guys and say, okay, help me figure out how to do this, right? So old fogies like me, and I've been told that you guys are not familiar with the term old fogey, but yes, old fogies like me, you go look up the term. Old fogies like me don't want to try anything when we're talking about technology, okay? I'm going to call you guys out if you're not going to be willing to try anything with this stuff, because it's the same type of idea. If you just stare at that problem and you don't try anything, then you're not going to get anywhere with the problem. So like I said, if the only thing you do is change into sines and cosines, at least you've done something. In other words, you've turned on the power button at least, and you've pushed the first button, but now you have to just keep going. Because inevitably, Rewriting in terms of sines and cosines is going to lead you to something else, more than likely, okay? So I'm giving you this heads up, over the course of the next few days, you do not want to be referred to as an old fogey, but you'll understand what I'm talking about. It means you're not trying anything, and you need to try something, right? So keep that in mind, please. Okay, we're not solving equations, but it looks like an equation because we have, so that's the other really awesome part about this, is before when we were simplifying, for some of you, you were kind of like, I don't know if I'm done yet or not. Now, the beauty of verifying identities is that we know that we are done because we know what our answer has to be, right? Think about that. We're starting with, in this case, we're going to start with the left-hand side because that's the more complicated side. And we're going to have to simplify it until we get to the point that it looks like the right-hand side. So we know what our final answer should look like. So keep this in mind and think about this for a second, guys. What it means is that the steps that you are showing me in between are very important. So you have to be very clear and methodical and careful with what you are writing from step to step. Okay? You work down the page kind of along that left-hand side in this case so that I can see each step. These quizzes and tests take a lot longer to grade just because I have to be able to look at and think through what you are thinking in order to solve these. Right? So the showing clear, precise steps is going to be important. All right, some of you guys have already solved this. You're like, let's just go. So what should we do first? I want to work on this left-hand side, and I need to do something so that we get it to look like the right-hand side. What do you want to do first? Thoughts or ideas? Distribute. Sure. Sounds good. So let's distribute. So that means we are multiplying sine x times secant x, and then minus sine x times cosecant x. All right. John, what does that equal to?
Is that like tan?
We're multiplying sine x times cosecant x. What does that equal to?
I'm not sure.
Look at your identities. It's an alternative form to the identity that I asked you to write in there. Say that again?
1.
1. Because, why? Because they are reciprocals of each other. If you multiply a number times its reciprocal, you're going to get 1. So sine x times cosecant x is equal to 1. We're getting close to what we're trying to get to. We need to simplify this. Sorry, let me change colors. Let me color code this. So let's go ahead. We'll keep the sine x the same, right? We already have a sine, so let's keep it as a sine. But let's rewrite this secant x. How can we rewrite that secant x? Zach?
Secant x with
1 over cosine of x. There you go. And if we combine together this sine x times this 1 over cosine x, then we have sine x over cosine x, and then minus 1. And yes, CJ, you just said this. Sine x over cosine x we know is equal to tangent of x minus 1. And guys, that's what we wanted. So the final step that you are always going to show me, this is very important. Your final step on every single one of these problems should be left-hand side equals right-hand side, and they should match. They should be exactly the same thing. So tangent x minus 1, we got that on the left-hand side, and that's what we wanted. So we have just verified our first identity.
So it has to be on the other side? Is that what you're saying?
So it has to be exactly what we saw on that right-hand side. Yep, across the line, basically, right? Awesome. Okay. Here's the other thing that you are going to notice as we start getting into more complicated problems. There are kind of multiple directions that you can go. Doesn't mean that you're wrong. There are, in some instances, kind of different ways of thinking through these problems and seeing what to do. As long as you're following good legal math steps, then you're fine, right? Okay. Clearly, the left-hand side is more complicated than the right, so we're definitely going to work with the left-hand side. Ideas, thoughts, suggestions of what we should do? What do you want to do first?
Like split those?
I'm sorry?
Could you split them?
We could split those. I like that idea. Yes, let's do that. So what she's saying is she's pointing out and realizing we have common denominators. So we can do first term over common denominator plus second term over common denominator. I like that. So let's do that. So we get tangent x over secant x cosecant x, and then plus cotangent x over secant x cosecant x. All right, now we need to be able to simplify anything in each of these individual fractions that we have. So we need sines and cosines. Okay, so CJ, help me out. Tan x, how are we going to rewrite that? Sines and cosines. Sines and cosines, be careful.
Oh.
We don't want to switch to cotangents, we want sines and cosines.
Wouldn't that become cosine over sine then?
Careful, tangent, not cotangent.
I thought you, so one side would be sine over cosine and the other side would be cosine over sine.
Okay, good. So tangent x is sine x over cosine x. Okay, all over. And then secant, CJ,
Yes, secant x.
is 1 over what? Cosine x.
X.
Good. Times cosecant x is
Is sine x.
1 over sine x. Okay. And we can do keep it, change it, flip it at this point, can't we? So if we keep change flip, then we're multiplying by cosine x sine x over 1. And what do we notice? What happens here, guys? If we have cosine x sine x times sine x over cosine x, what happens there?
The cosine cancel.
The cosines divide out. So this divides out with this. And what are we left with? We're just left with that there. So we're left with sine squared x. Okay, so all of that tangent over secant, cosecant business, it just simplified to sine squared x. Okay, we got to do similar process for that green term, the cotangent over secant times cosecant. So let's do that. Okay, so cotangent, CJ,
Is the reciprocal, so it's cosine x over sine x.
there you go, cosine x over sine x over, let's go ahead, we know we need that 1 over cosine and that 1 over sine, and we know we have that. And we need to do keep it, change it, flip it. So cosine x times sine x all over 1. And what happens over here?
Sines cancel.
Sines divide out, and we are left with plus cosine squared x. Whose identity is that? Dina, I think that's your identity? That's Dina's identity, right? Sine squared x plus cosine squared x is equal to 1. So we get that 1 is equal to 1. Boom. Nice.
Wait, Sarah,
Yes.
I don't get how you get like one. How do you get from secant x times secant x to cosine x? 1 over cosine. Oh, no, I got it.
You see it?
Sorry.
Okay. No, that's fine. Sometimes you just have to kind of talk through it for it to process. So good. Okay. Onward. All right. Number 3 here. Definitely working on the right-hand side. And I don't know, what do you think what should we do first? Alex Subin, what should we do? What do you think?
Separate the parentheses.
S-
Distribute.
Okay, so, yeah, let's distribute and then we'll kind of separate and see what we've got here. Okay, so when we distribute, we get tan x sine x plus tan x cotangent x cosine x. Guys, what's that equal to there that I just highlighted? 1, right? Those are reciprocals. So you definitely have to look for when a whole bunch of different trig functions are getting multiplied together, look for that type of thing if you've got reciprocals, because that kind of cleans up pretty quickly. All right, we also, I'm kind of doing an intermediate step there. We need to rewrite in terms of sines and cosines though. So this tangent we want to rewrite as sine x over cosine x times sine x over 1. And then here we just have cosine x over 1. So when we combine like terms, we have this. We have sine squared x over cosine x plus cosine x over 1. I'm seeing fractions that we are trying to add. So what do we need? Common denominator. There you go. Yes. So we got to multiply by cosine x over cosine x. Hopefully this one looks like the format should look a little familiar to something you saw on the simplifying page that we did. There's kind of a pattern that starts to develop on some of these that I'm hoping that you will pick up on. Okay. And once again, we've got Dina's identity, right? Sine squared x plus cosine squared x. We know that's equal to 1 over cosine x. And guys, what's that equal to? 1 over cosine x is secant x. And what did we want this to be equal to? That's what we wanted. So we are done. Okay. All right, what do you think so far? Pretty good? All right, when we start working through these, here's the deal. You have got to be following along and trying to understand the steps in the process, because it's gonna go a lot quicker and easier when we have a bunch of brains thinking and talking through these problems together. So if we start going too fast and we need to slow down, you've got to say that, right? We'll go back and talk through a step. But
We're gonna have a unit test on this?
yes, there will be a unit test on this. And there's a quiz day 1 of this next week.
Thank you.
Yes. All right. A few more to look at. And this trick is really, really, really important. So we'll get to that in just a second. We've reviewed adding and subtracting and finding common denominators. So I'm not going to worry about those. So we're going to look at number 4 and then talk about this special trick. And then I've got a couple other little tricks, one other trick to show you. And then I want you guys to try some of this. Okay. Thoughts about what to do here? We're definitely working on the right-hand side.
Multiply by the other.
There you go. Yeah, because we need common denominator. It's exactly right. So this fraction has to get multiplied by 1 plus sine theta, top and bottom. This one's got to get multiplied by 1 minus sine theta. So it's a little bit messy to write that in there. Okay, so let's see what we have though when we do that. Our numerator is going to be 1 plus sine theta all over. If we FOIL that, our outside and inside are going to add to 0. So we just end up with 1 minus sine squared theta. And then plus 1 minus sine theta all over 1 minus sine squared theta. All right, now let's put this all together under one, on the one common denominator, but we need to combine like terms too, don't we? So sines, what happens with those?
Cancel.
Those add to 0. So in the numerator, we're just left with 2. Our denominator, we have 1 minus sine squared, which we know is equal to? Yep, say that again really loud. Cosine squared theta. There you go. Cosine squared theta, right? If it is helpful for you to think about where we are headed and what we're trying to get to for our final answer, if you need to see a 1 over cosine squared theta to help you realize that that's equivalent to secant squared theta, then put that 1 in there if you think that's helpful. Otherwise, if you can see straight from that 2 over cosine squared theta to 2 secant squared theta, then you're good to go too. So either way. All right, but 1 over cosine squared theta is equal to secant squared theta, and that's what we wanted, so we are done.
Wait, so if the two problems, like, on both sides don't equal the same, what would you do? Just, like, put, like...
Great question. If you don't get that they're equal, then you've done something wrong, because I will tell you guys, in my earlier class they asked, it was like, are all of these going to verify? Yes, all of the ones that I am showing you, they will verify. So in some resources, some textbooks, they ask you, they say, you decide whether it works or not. I'm telling you, all of these will work. So if you don't get that they check, left-hand side equals right-hand side, then you know something's gone wrong and you better go back and kind of look through your work. Great question. Okay, here's the trick. I need you to look at this particular problem. I need you to notice a couple of things about the format of this, and then I would suggest you make a note about this. So the first thing to notice is it looks like a proportion, right? It looks like we could solve using proportions, but remember, we're not solving equations. But that's kind of one of the things you can look for. If it looks like a proportion, there should be a little bell going off in the back of your mind going, oops, this is probably that trick. Okay? You don't have a bell ringing in the back of your mind when stuff like that happens, Zach? You're giving me this weird look. Okay. All right. That's okay. All right, the other thing to look for and notice that more than likely you're going to see is you're going to see a 1 plus or minus a trig function. And whichever side that 1 plus or minus the trig function is on in the denominator, that's the side that you're going to solve on. So in this case, we're going to simplify this side. Okay? Because the 1 plus trig function is in the denominator on the left-hand side. So we're going to work with the left-hand side. So those two things to look for. And then that little bell should go off in the back of your brain saying, oops, this is the trick and I have to remember what to do, because if you don't, you're out of luck. You have to remember this trick. So the trick is that you are going to multiply top and bottom, obviously, by the conjugate. So that is key, is remembering that, because if you don't and you try solving this problem, there's nowhere else to go. So this is an important trick to keep in mind. So remember what the conjugate is. We keep the sign the same for the first term, we switch the sign for the second term. So that means we are going to multiply top and bottom here by 1 minus cosine theta on top and bottom. Okay? My suggestion, do not distribute immediately. Keep this, because many instances you don't want it distribute, you don't want to distribute in order to be able to see what's going to divide out. And sometimes you do have to distribute, but more often than not, you do not. So don't distribute to begin with in the numerator. In the denominator, if we FOIL this, outside and inside are going to add to 0. That's what's beautiful about conjugates, is that we just get first and last. So in the denominator, we just get 1 minus cosine squared theta And that's alternative form for Dina's identity. So we have this now. We have, in the numerator, we have 1 minus cosine theta times sine theta. In the denominator, let me highlight this and change colors here. In the denominator, we get sine squared theta, right? 1 minus cosine squared theta is equal to sine squared theta. Guys, what happens with the sine in the numerator and the sine squared in the denominator? Yep, this divides out with one of these, so we still have one left in the denominator, but the one up top disappears, divides out, and so then we have 1 minus cosine theta all over sine theta, and that's what we wanted. Okay. All right. One last example that I'm going to talk you through, and there's a little bit of a trick on this one too. Nothing like this last one though. You have got to remember that trick. Okay, what I want you to notice on this one is that on the left-hand side, we have 2 different trig functions, but on the right-hand side, we only have 1 trig function. So if you see that in some instances, the trick is going to be that you're going to realize that you want to rewrite this. So we're going to substitute in place of that sine squared a, we're going to rewrite, and we're going to think about what we know sine squared, how we can rewrite that using an alternative form for our identity. That way we're only in terms of cosines, right? So we're going to keep that first cosine squared the same. And in this case, we're using a. I'll use that. So minus, now I want parentheses here. Alternative form for sine squared that involves cosine squared. Right? Think about that. It's 1 minus cosine squared a. Do you see that, guys? All right, and now we've got to distribute. So this becomes a minus 1, but then a minus the negative becomes plus cosine squared a. And we already have this cosine squared a up front. So if we have 1 cosine squared a plus another 1 cosine squared a, then we have 2 altogether. And that's what we wanted. Okay, so there's a little bit of a trick on this one too, just in terms of noticing that you're doing like a substitution there, basically, right? Okay, I would like find partners, find 1 or 2 people to work with. I'd like you to try 7, 8, and 9 yourselves, and we'll go over those here shortly, okay?